In this video, we're going to use the calculator to evaluate some exponential and logarithmic expressions. So just basically getting familiar with um, using your calculator for these problems. So the first example, we're going to use the calculator to evaluate A, log base 10 of 100, B, log of 100, C, 10 squared, and D, log base 4 of 4. So let's just skip across here and I'll bring up the calculator. Well, first of all, I'll write the problem for A first. Let us take a look at example 1. A was to just use the calculator showing log base 10 of 100. And with the calculator, you can see if you're using the Casio, I think it's the 991, you will be able to find the button of log base, which is just here. I'm pointing to it here. So we're looking to do log base 10 of 100. And it's a simple problem. Log base 10 of 100 is indeed 2. Now, the second problem was just simply using the log button, log of 100. So when I bring up the calculator and I see I have a log button here. Now this log button assumes base 10, and that's why this example is here, just to remind you that when you see the log button, it is log base 10. So we'll clear the previous problem. We'll just do log of 100 and we should get the same answer, equals to 2. Yes, indeed we do. And then the third example is just really showing how logs and powers are related. So if we do 10 to the power of 2, I don't think we even need to use the calculator. We know that that is 100. So you can see here the relationship. 10 squared equals 100 is one way of expressing the relationship. We can express it in log form, so log base 10 of 100 equals 2. And the last example we had, example C, was log base 4 of 4. So if we have your calculator with the base function and we put that in, we will see log base 4 of 4 is indeed 1. So if you have the same base as value inside the log, then we will always get 1. So the rule is log base A of A equals 1. So that's the first example. Let's take a look now at some other examples relating to logs. So the second example, okay, we've got a number of things here. So we want to use the calculator to evaluate each of the following and then write the expression in an equivalent power form. So we're going to, first of all, on the calculator, we'll take each of these one at a time. The first one is log base 3 of 729. So let's go across log base 3, log base 3 of 729 equals, and we'll go to the calculator, log base 3 of 729 is 6. Now if I was to write this in power form, I'd be saying 3 to the power of 6 is 729. And you can verify that. Let's just quickly verify that. So 3 raised to the power of 6, 729. Great. So the next example that we needed to look at was log base 2 of 25. B, log base 2 of 25. So B is, that was A, B is log base 2 of 25. 2 of 25 is, now what did we do here? Log base 2 of 25. No, I think I should have probably, I'm going to go back and change that. It should have been log base 5 of 25. Or we leave it, because that's what let me just double check the example. Yes, I did write log base 2 of 25. It should probably have intended to say log base 5 of 25. But we've done it, so let's take a look. We've done it there, so we get 4 point, what did we get? So go back. 4.638, so I'll round that to 3 significant figures, 4.64. 4.64. So in theory, if we were to raise 2 to the power of 4.64, we would get approximately 25. I think that problem should really have been log base 5 to the power of 25 equals 2, and 5 squared. 5 squared is indeed 25, and so on. So we can look at the next example. C was log base 6 of 216, and log base 6 of 216, log base 6 of 216 is 3. So we could say 6 to the power of 3 must equals 216. Next problem. Log base 5 of 5. Okay, we had this previous example. Log base 5 of 5 is 1. Let's just make a note of it. Log base 5 of 5 equals 1. Next example. Log base 5 of 5 squared So we have example E, log base 5 of 5 squared, which is log base 5 of 25, which we've got up here. If you do it on your calculator, you will see that gives you 2. And then the final example, F, is log, let's have a quick look. It's 2 log base 5 of 5. So 2 log base 5 of 5. So we know log base 5 of 5 is 1, so 2 log base 5 of 5 must equal to 2. So just looking at these two show you one of the important rules of log. So if I have log base a of b raised to some power n, it's always equal to n times log base a of b. So that's just one of the important rules of logs. So the final example we look at in this video is in example 3. So we use the calculator to evaluate the following, and this time we're looking at ln on the calculator. ln on the calculator. So let's just take the first one, ln2. And I'll bring up the calculator. We've got the ln button. Now the first thing we're trying to do is ln 2. close bracket. So ln2 will give me a decimal figure, and I'll say again two significant figures, 0.69. I have maybe three significant figures, 0.693. So in the first example, ln2 equals 0.693. That's 3SF. Example B is log base E of 2. And using the calculator, this time we'll go log base E. Now E, you will see above the ln button, that's e to the power of. So we're going to shift E, and it'll be e to the power of 1. And inside of that, so we've log base E of 2. And we get indeed the same answer. So log base E of 2 equals 0.693. That's again 3SF. And what I wanted to show with this is the button on your calculator that says ln is in fact log base E. And we'll just look at the final example. Is if we were to have e raised to the power of ln2. Let's take a look at that. E raised to the power of ln2. And again, we'll use the calculator to do this. So we'll just clear down the last example. So shift E raised to the power of ln, and inside my ln I'll have 2. And I do get 2. So what that's telling me, e to the power of ln2. So the function e and the function ln really are cancelling each other out. So e to the power of ln2 will give me 2, or e to the power of ln any value, we call it a, always equals a. So that's it for this video, and thank you for watching.